Good morning, dear students, and welcome back to online video classes. In chemistry, we already have started with lesson 3, metals and nonmetals. Last day, we started with chemical properties of metals. Today, we will continue with chemical properties of metals and we will see the reaction of metals with water and dilute acids. So the first is reaction of metals with water. Generally, metals form respective hydroxides when they react with water. Let us consider reaction of sodium metal with water. Sodium metal vigorously reacts with water and forms sodium hydroxide along with lot of heat and release hydrogen gas. Reaction of potassium with water. Potassium metal also vigorously reacts with water and form potassium hydroxide along with lot of water releasing hydrogen gas. Lithium, sodium and potassium when reacts with water gives corresponding hydroxide along with release of hydrogen gas. The reactions are exothermic. Heat is released. We can see the word equation as well as balanced chemical equation for each. The metals, sodium, potassium and lithium react violently with water to form corresponding hydroxides and hydrogen gas. So much heat is produced during these reactions that hydrogen gas formed catches fire and burns explosively. Whereas if we consider calcium as metal, calcium reacts readily with water. Calcium when reacts with water gives calcium hydroxide along with hydrogen gas. Calcium hydroxide is slightly soluble in water. So once the solution is saturated, it starts to form milky as solid calcium hydroxide appear. We can see this particular reaction as an activity where the apparatus below is used to show the reaction between calcium with water and collection of gas. The same experiment would not be used with sodium, potassium or lithium as they float and the reaction is too vigorous. So the activity shows a beaker where calcium is placed at the bottom of it. Over this inverted filtrate or filter funnel. The top of the funnel is closed by boiling tube or test tube. When we fill the beaker with water, we do observe bubbles coming out. The calcium metal bubbles and fizzes in water to form calcium hydroxide solution and hydrogen gas. Much less heat is produced in this reaction, due to which hydrogen gas formed does not catch fire and burn. The piece of calcium metal starts floating in water because the bubbles of hydrogen gas formed during the reaction stick to its surface. The reaction of calcium metal with water is less violent and occurs in cold water itself. As the metals sodium, potassium, lithium and calcium react with cold water, some of the metals react with steam and hot water. Magnesium reacts very slowly with normal water and cold water. However, it reacts vigorously with steam. It also reacts with hot water to form magnesium hydroxide along with release of hydrogen gas. In this particular example, we are observing the reaction of magnesium with steam, which occurs very rapidly to form magnesium oxide along with the release of hydrogen gas. Metals which react with steam form the solid metal oxide and hydrogen gas. In general, the more reactive the metal, the more rapid the reaction. Aluminium is unusual because it is a reactive metal that does not react with water. Actually, its surface forms a protective layer of aluminium oxide that keeps water away from the metal below. Therefore, the utensils used at home are of aluminium but do not form any such reactant or different type of product with the use of water continuously. Below is the picture. The next slide shows the picture where the metals react with steam and we can see the collection of hydrogen gas. We do have a test tube which has a lump of glass wool soaked in water placed at the bottom of it. A metal sample is also placed in it, horizontally kept, attached to the delivery tube, and the end of the delivery tube is immersed with glass straw and glass jar filled with water. When we start the activity, we do heat the metal first using a burner. When the metal gets hot, the next glass wool is heated by using another burner. The water present in the glass wool forms steam on heating. This steam then passes over the hot metal. The hot metal reacts with steam to form the corresponding metal oxide and hydrogen gas. The hydrogen gas comes out of the boiling tube and it is collected over glass in the glass jar. The gas burns with pop sound while making a little explosion, indicating that it is hydrogen gas. The metal oxide formed remains behind in the burning or boiling tube, test tube. So we have metals reaction with water to form metal oxides or metal hydroxide and hydrogen. Sodium reacting with water forming sodium hydroxide along with evolution of hydrogen gas. Potassium reacting with water forming potassium hydroxide along with evolution of hydrogen gas. Calcium reacts with water less violently, forming calcium hydroxide along with release of hydrogen gas. Aluminium reacts with water as in the form of steam to form aluminium oxide and hydrogen gas. Usually the aluminium is non-reactive as I specified because it reacts with oxygen forming a protective layer of aluminium oxide already. Iron also reacts with water to form iron 3 oxide or ferric oxide along with release of hydrogen gas. The reactivity of different metals with water is different. Sodium and potassium react violently with water to form sodium hydroxide and potassium hydroxide respectively and hydrogen gas. The gas catches fire. Calcium reacts less violently with water to form calcium hydroxide and hydrogen gas, and the gas does not catch fire. Magnesium reacts only with hot water to form magnesium hydroxide along with the release of hydrogen gas. Metals like magnesium, aluminum, iron, and zinc react only with steam but to form metal oxides along with hydrogen gas. Metals like lead, copper, silver, gold, platinum do not react with water. This shows the reaction of iron with water. Prolonged exposure of iron objects in water results in formation of both iron 2 oxide as well as iron 3 oxide along with the release of hydrogen gas, and these compounds collectively are known as iron 2,3 oxide or ferric oxide. This table shows the reactivity of metals with water giving the variable products. The intensity of the reaction of a metal with water depends on its chemical reactivity. Some metals react even with cold water, some react with hot water, some react only with steam, whereas others do not react even with steam. Steam, which is very hot and gaseous form of water. So potassium, sodium violently react with cold water. Lead, silver, gold, copper do not react at all with water. Magnesium, aluminum, iron, zinc, they do react with steam to give oxides, whereas magnesium react with hot water to give magnesium hydroxide. The reactions, if occur, release the hydrogen gas, which is the H plus ions from water. Sodium reacts vigorously with cold water. Magnesium reacts with steam forming oxide. Aluminium reacts again with steam when hot, forming aluminium oxide. And in each case, hydrogen gas is released. When a copper vessel is exposed to moist air for a long time, it develops a green layer on its surface. Copper actually corrodes by the oxidation in which it reacts with oxygen in the air to form copper oxide. Copper oxide then combines with carbon dioxide to make copper carbonate. Copper also combines with water present in moist air or moisture and forms copper hydroxide. This gives a green color. We can understand the reaction of copper with moist air as copper plus water plus carbon dioxide plus oxygen. These three components or reactants are in moist air. On prolonged exposure of copper vessels or utensils or articles give copper hydroxide and copper carbonate. The two are the products which give the green coating deposited on the surface of copper vessels. This is basic in nature. So we can say that metal when react with water produce metal hydroxide or metal oxide along with the release of hydrogen gas. You have to write the equations for the following, both word equation as well as formula equation using the symbols and balance the equation. Sodium reacting with water, potassium reacting with water, and lithium reacting with water. Water actually is slightly ionized because of the salts present in it to give hydrogen ions and hydroxide ions, H plus and OH minus ions. Now, when a reactive metal combines with water, it gives electrons to reduce the hydrogen ions of water to hydrogen atoms, which then form hydrogen gas. The non-reactive metals or unreactive metals like copper, gold, silver do not give electrons easily. So they are not able to reduce the hydrogen ions of water to give hydrogen gas. Hence, unreactive metals like copper, gold, silver do not displace hydrogen from water and we do not find any product. The next is reaction of metals with acids, dilute acids. Since we are using the mineral acids, the little amount of acids are sufficient enough to find or get the result. So we are taking the dilute acids. When a metal reacts with an acid, the products are a salt and hydrogen gas. Metals usually displace hydrogen from dilute acids. Only the less reactive metals like copper, silver, and gold do not displace hydrogen from dilute acids. The salt produced here by the reactive metals depend on the metal itself and the type of acid involved in the reaction. When a metal reacts with hydrochloric acid, the salt produces metal carbonate, metal chloride. When a metal reacts with sulfuric acid, the salt produces metal sulfate. When a metal reacts with nitric acid, the salt produced is a metal nitrate. We can also find this by an activity where a test tube is attached to stand. In it we can have a few granules of zinc and dilute sulfuric acid. Close the test tube with the help of cork, attach the delivery tube, the end of the delivery tube in a trough filled with water. After a few minutes, we will see that bubbles coming out from the end of the delivery tube immersed in water or soap solution. When these bubbles or soap bubbles filled with hydrogen gas is brought to close to a burning candle, burning of hydrogen gas result with a pop sound. So all the metals which do react with dilute acids can have the common thing evolution of hydrogen gas taking place along with the formation of salt ionic compounds. The vigor of the reaction of a metal with dilute acid again depends on its chemical reactivity. Some metals react explosively, extremely rapidly with dilute acids. Some metals react rapidly. Some metals react only on heating, whereas others do not react at all. We first will see the example of magnesium reaction with hydrochloric acid forming magnesium chloride, the salt, along with the release of hydrogen gas. Aluminium reacting with hydrochloric acid, diluted hydrochloric acid, and it rapidly forms aluminium chloride along with the release of hydrogen gas. Zinc reacts with dilute hydrochloric acid to give zinc chloride and hydrogen gas, but the reaction is less rapid than that of aluminium and magnesium. Sodium reacts violently with dilute hydrochloric acid to form sodium chloride, and hydrogen gas. This reaction shows that sodium metal is very reactive. Iron reacts slowly with cold dilute hydrochloric acid to give iron 2 chloride or ferrous chloride along with the release of hydrogen gas. Magnesium reacts with dilute sulfuric acid to give magnesium sulfate and hydrogen gas. Aluminium reacts with dilute sulfuric acid to give aluminium sulfate along with the release of hydrogen gas. This shows the reaction of metals sodium, iron, magnesium, and aluminium with dilute hydrochloric acid and dilute sulfuric acid respectively, but the reaction is in the form of formula equations only. We can write also the word equation to understand the product and the nature of the reaction. So the reactivity series of metals, which we already have had studied in class 8 also, help us to know how violently, vigorously the metals react with acids. The metals which are at the top of the reactivity series will react violently with the acids, whereas the metals which are below hydrogen do not react with acids and therefore are considered as least reactive metals. The reactivity varies from metal to metal. Copper, silver, gold do not react with dilute acid. Hydrogen gas is not evolved when metals react with nitric acid because it is a strong oxidizing agent and it oxidizes the hydrogen produced to form water and itself reduced to the oxides of nitrogen. Whereas copper do react copper reacts with very dilute nitric acid to give copper nitrate along with water molecule and nitrogen dioxide. Nitric acid do not react with aluminium as well because of formation of layer of aluminium oxide on aluminium objects. So we can say that reaction of metals with acids give salt and hydrogen. Since all acids contain hydrogen, we do have displacement of hydrogen by the metal as in the form of ions to form or get the salt. The salt form depends on the acid used. Nitric acid forms nitrate salt, sulfuric acid forms sulfate salt, and hydrochloric acids form chloride salts. When we consider these, we have a mixture of 1 part of concentrated nitric acid and 3 parts of concentrated hydrochloric acid when freshly prepared as aqua regia. The ratio of concentrated nitric acid and concentrated hydrochloric acid in aqua regia is 1:3. Why is this so important? It is a highly explosive fuming liquid and can dissolve all metals. For example, aqua regia can dissolve even gold and platinum metals. So, concentrated nitric acid and concentrated hydrochloric acid as in the mixture form freshly prepared in the ratio of 1:3 dissolve the metals and used in the purification. These acids cannot be used alone to dissolve these metals. So we have today studied the reaction of metals with water and acids, dilute acids. In our next class, we further will continue with other properties, chemical properties of metals. Thank you.